Hello guys, welcome to the course PLC for beginners, and today we are going to start lecture number 3, digital output of PLC. Before moving forward, let's take a quick recap. So in the last lecture we covered 2 points. First was syncing and sourcing, and the second point we covered was digital input of PLC. Before moving further to this topic, let's cover what the difference between digital and analog signals. Okay, so I will be explaining this topic with help of an example. So digital and analog signals. Let's assume it's a fan and we have two options. Either we can on the fan or we can turn it off by pressing the switch. Okay. It will be either 1 or 0. It will be either high or low. So you can see here in the example that how many possibilities are we getting here. So we are getting two possibilities. So in the digital signal, there are very few number of possibilities. So we can write that if number of possibilities are finite, it's called digital signals. Continuing this example, we can also understand what is analog signal. So again, we will take the fan. And to control the speed, we have a fan regulator. So you can control the speed from 0 to 100. By rotating the knob, you are controlling the speed of the fan. And you can see that there are infinite number of possibilities. So we can write that if number of possibilities are infinite, it's analog signals. Now let's come back to our topic, digital output. In PLC. So there can be two different type of digital output. One is relay based digital output and the other one is solid state digital output. First we will cover what is relay based digital output. So there can be three different types of relays. First will be it's a anode type relay, anode type, or you can say A type relay. The second one is NC type relay, you can say B type relay, and the third one will be both NO and NC type relay. This is NO slash NC type, or you can say C type relay. I will be taking example for NO NC type relay, which is the C type relay. So let's assume this is our PLC. So let's make a PLC output. As I will be taking NONC type, so we'll make the NONC type. And we'll have one common output. So it will be common output. And we will have here NO1, NC1, NO2, NC2. Here you can see that I have taken a common output for both the relays, but in the market the PLCs are also available where you can take individual common for every single relay. So let's connect the load. We'll take a lamp here to the NO, and we'll take a lamp here for NC. And let's take a power supply, AC power supply. In the relay based system, you don't have any limitations. You can connect both AC and DC power supply. Just go to the manual, you can get the data. So as per the current scenario, the NC2, this relay will be turned on and the supply will be here. The lamp will be lamp 2, lamp 1, lamp 2 will be on. But once, as per the logic or input we give, if this NC become NO, it will get connected here. The lamp 2 will also be on. So this is basic for relay. Now let's move to the solid state type digital output. The solid state is further divided into two. One is static and the second one is transistors. You can say BJTs. The difference between both of them are static is used for AC sources and transistor are used for DC sources only. So let's take first BJTs, transistors. So there will be two different types of transistor always in the PLC. One will be PNP and the other will be NPN. If you remember, in the last lecture we covered syncing and sourcing, but in the digital type we don't say syncing and sourcing, we say basically PNP or NPN type module. The PNP module are basically the sourcing type and the NPN modules are syncing type. I will make a quick diagram of how they look. This is the NPN type, which is syncing. Now let's make sourcing. PNP type sourcing. So as I mentioned earlier, there are optocouplers present, and these optocouplers gives the signals to the NPN or PNP or any different type of digital output available. Now let's move to the TADIAC. Let's make a PLC first. This is our TADIAC. Let's take two of them. Let's take two of them. Let's take the common output for them. And as I mentioned earlier, the source always for the TADIAC will be AC source. And let's connect some load. We'll connect a lamp here and we'll also connect a lamp here. And the optocouplers, as I mentioned earlier, will be here. As per the logic, the optocouplers will give signal to the TADIAC and the TADIAC will turn on or off and the lamp will get turned on. So in this lecture of digital output, we have covered both the digital output. First was relay based, in which we saw all the three different types of relay: NO, NC and NO/NC type. And also we covered the solid state digital output, in which we covered TADIAC and also we covered transistors. And we saw that TADIAC used for AC sources and transistor used for DC sources. And these relays can be used for both AC/DC sources. That's all for this video, and in the next video we are going to cover the topic analog input and output of the PLC. If you enjoyed this video and find it helpful, please like, share and subscribe, and also share it with your friends who are interested to learn PLC. Thank you.